All right, so extraction is now fully working, which means we're kind of done with the ingestion phase of the pipeline. Now, before we move on to the ideation phase, there are some improvements that we should implement. So let's take another quick look here at the triage and extraction steps, right? So here we have the triage step. We have some inner classes. We do all the processing here. This is where we do the UUID to index mapping and back. So it's not a huge method, but then looking at extraction step, it basically looks identical, right? We're kind of doing the same thing. And we kind of knew that because we told it to follow the same pattern when we implemented this. So I think there's an opportunity to refactor things. These are going to be the only two steps in our pipeline that deal with batches. So once we're done with these two steps, everything else is going to take a bunch of inputs, but then send those to the LLM in a single prompt and then get a result back. And then we'll kind of successively refine it until we have the final newsletter. So the triage and extraction step share this kind of batching logic. And I think we can maybe extract this out into a superclass that encapsulates some of this, and that'll give us a chance to implement optimizations in a single place. The other thing that we're going to do, and let me switch over to the diagram for that. So if you remember, this is what we're doing for the fetch step, where we split things into batches of 40, and then essentially the same thing for the extraction step with batches of 10. Now, each of these batches is processed sequentially, and we don't have to do that. We can actually run a whole bunch of these batches at the same time and introduce parallel processing to the application. So the architecture that we're aiming for will look something like this. So pretty similar, just sort of this section in the middle, right? So right after we split it into batches of 40 for the triage step, we can actually run 5 of those batches at a time. Now, this isn't a rigid number like any of the numbers in the pipeline. You can tweak this. This will depend on the LLM that you're using, like what the rate limits look like, whether you have a paid API key, things like that. For me, 5 has worked pretty well. I could probably go higher as well, but 5 generally keeps things pretty reasonable, especially if you're running this pipeline daily. That means that every run will take just a few minutes. We're getting all the articles, we're batching them up, running 5 batches at a time. At the end, we're going to collect all the results, and everything else stays the same. And it'll look the same for the extraction step. Let's actually clear our conversation so we can start with a fresh context. All right, so here's the prompt. The triage and extraction step share the same structure with some duplicated code. Let's extract the shared logic into a base class to clean up the code. Also, the extraction step is very slow because of the many sequential agent calls. We can speed this up by running multiple agents in parallel. Refactor to create a BatchStep base class that both triage step and extraction step extend. It should encapsulate batching logic with a configurable batch size, the index to UUID mapping, and parallel batch processing using async IO with a semaphore with maximum 5 concurrent batches. This will require making the agent calls async. Each step should only need to define its batch size, the agent and prompt configuration, how to build the prompt for a batch, and how to extract results from the LLM output. Keep the step-specific logic, system prompts, models, field mappings in each step class. All right. This looks complicated enough that I'm going to do plan mode. Okay, here is our plan. Context, I mean, that's basically basically just what I asked it to do. I like this little diagram here. I actually really like how natural sort of ASCII art comes to these agents. So we have the pipeline step as before. We have the fetch step as before. Now we're implementing a new abstract base class called BatchStep, and then Triage step and Extraction step both extend that one, and they can both be simplified. So that's exactly what we're looking for. So it's implementing this. There's some generic inputs and outputs. Process now calls asyncio.run. Process batches uses a semaphore to run 5 in parallel, and then gather at the end to collect all the results. Run batch builds index map, formats prompt, calls await for the agent to run. Yeah, some abstract methods to map the results. So that's how we delegate the specific implementation to the concrete subclasses. Here's the abstract methods. I think this all looks solid. Triage step, okay. Extraction step, same thing. Different batch size, different inputs and outputs. Remove the module level constants. The CLI doesn't need to change. It's calling out that the logs may interleave the log messages because some batches may finish before others do, but the batch numbers make them identifiable. So I appreciate the attention to detail there. So that looks good. Let's do it. Okay, it finished. It says that the tests pass. Well, let's just take a look at the code. So only 2 classes had to change. Base. Okay, we have a constant here for the maximum number of concurrent batches. And then we have our abstract batch step. We have some abstract methods that the concrete subclasses need to implement. So like how to format the prompt, how to extract the indexed results, things like that. So the process method now calls process batches. And that creates a semaphore, passing in the number of max concurrent batches. Then we batch things up, run each batch, gather the results, collect all the items here, and then return that. And then run batch. Looks somewhat similar to what we had before in the concrete class, right? So it formats the batch prompt, runs the agent, extracts the results, maps them back, and returns the outputs. Okay. Looking at the steps class, or rather the steps file. Bunch of changes. So we cleaned up those constants that we don't need anymore. So the triage step, the definition changes a bit because now we extend batch step. Batch size is now a method in here. This whole function is gone because that's basically mostly generic. Here's the function to extract the indexed results, map the results. So in this case, we're returning triage decisions. All right, I think that's nice and clean. And then extraction step should look very much the same. So mostly we're able to delete a whole bunch of stuff and then add a little bit back to do the mapping here to article insights. So I think this looks nice. Let's make sure our tests still pass. Looks good. So if we run it now, chances are we won't really be able to see much of a difference because we just ran it and there just aren't a whole bunch of articles to process. Now, I'm wondering, one thing we could do is just delete a bunch of those article insights from the database, and then it should be able to pick them up again this time. So if I wanted to, I could whip up a SQL query by myself and delete the last couple hundred article insights maybe. But just so we can demonstrate another use case for Cloud Code, let's start a fresh conversation. All right, so I'll ask it to write a SQL query that deletes the 200 most recent article insights from the database. There we go. So I certainly could have written this, delete from article insights. Oh, interesting. Delete from article insights where ID in, right? We do another nested select ID from article insights, order by created at desk, limit 200. If the table doesn't have a created at column, let me verify, but it does. So, okay, so it actually had to verify first whether the table indeed has a created at or not. So this should work. I can just click on this here to copy it. And we'll just run it here in the shell. Paste it. All right. So that should have deleted the last 200. So we can get back out of here. And now we will run our pipeline again. And we should have at least 20 batches or so to process. Nothing new to triage. But extraction, see, yeah, 20 batches. Makes sense. 200 articles. So it looks like here it kicked off the first 5. Some of them are finishing. As they finish, it kicks off new batches. So only 5 will ever be running at the same time, but it doesn't have to wait until all those 5 complete before it kicks off the next couple of batches. So the semaphore kind of handles that elegantly for us. Okay, yeah, that was much faster. So already a big improvement. Let's maybe take one more look in the database just to make sure. Okay, so here's the latest article insights in the database. So it looks like it's working just fine. Demand for supply chain resilience and alternative logistics. All right, no need to look at these in details, but this looks great. Let's commit it. So with that, we're done with the ingestion phase. In a way, the triage and extraction steps are actually the most complicated ones, just because we have a huge input size. So we need to be smart about batching. We've seen how we can use parallel processing as well to further cut down on the runtime. We had to do a little bit of prompt engineering to get good results. So I think we're in a pretty good place now to be able to start the ideation step next. In some ways, those next steps are going to be a little bit simpler. So stay tuned.